Good afternoon all, this is Jisha, welcome to our channel. So today I will do polynomial fitting using numpy Polyfit. So it's very simple. So if you have some kind of data and you know that it has to be fit to a polynomial, you can use this function and you can fit your data, and you can also use it for many different things. It depends upon your problem. So if you like this video, do subscribe to our channel and click the bell icon for notification. So let us see how to do polynomial fit. So the simplest polynomial is a line which is a polynomial of degree 1 and which is given by the equation y is equal to mx plus c, right? And similarly you also know quadratic equation which is a polynomial of degree 2 and it is given by y is equal to ax square, note this, ax square plus bx plus c, right? So and you have the polynomials of higher degree, so you just increase the degree here and you write it in a series, right? So what Polyfit does is that it will calculate all these coefficients m and c if you are calculating for degree 1, a, b and c for degree 2 and so on. So for simplicity, let's start with a line. For that, as usual, I will start my code with import numpy as np, and then I also want to plot these things, so I will use import matplotlib as plut. So now you have x is equal to I define x is equal to np linspace from -10 to 10 points. So I have 10 points from -10 to 10. So I define x like that, and y I define mx plus c, where my slope is 2 and 5 is the constant. So you know this is a simple thing. So if you run, which is shift enter, you will get the plot. So here for the plot, what I'm doing is, instead of plotting a line, I'm just plotting circles. For every point I plotted a circle. So assume that this is your data. So it need not be a straight line like this. This is the ideal case. So this is your data, and you have only 10 points, right? So what you can do now, for first, if you have such a data and looking at it, you know that it looks like a polynomial. So it's not a trigonometric function, it's a polynomial. So you want to fit this data. So you can use Polyfit, which comes from the numpy package. Okay, so the syntax is quite easy. You can also check the documents, numpy Polyfit documents, for the for all the parameters you can use. So the syntax, what you do here is, I define polynomial coefficients equals np Polyfit, and I give the functions which I want to give, the x and my data y, and then I say fit it into a polynomial of degree 2. So if I do like that, I already run this and I calculate what is polynomial coefficient, what are the polynomial coefficients which it calculated. So it's calculating the coefficients of a polynomial of degree 2. So but this data we already know is a straight line. It's not a polynomial of degree 2. So if you look at the coefficients, the terms square of x square are 0. It's e raised to -16. They are 0. Terms in x is of the power the coefficient is 2, and the constant term is 5, which is in fact what we gave. Our original line was y is equal to 2x plus 5, right? So it will calculate this coefficient. So if you give the data, it will calculate the coefficient. So you can also ask and you can fit it to it. So what I will now do is that now I will define a new x which ranges from -20 to 20, and it has 100 points. So if I plot this, and y new I plotted as y new. What is y new? I said this is this thing you have to check, poly 1D, NP poly 1D, and I give the polynomial coefficients which I just calculated. So what it does is it will give you back the curve, original curve. So let's see. So I have x new and y new, which is the new polynomial I will generate from the polynomial coefficients I just obtained. So I will plot like this. So the solid lines are x new and y new, which is calculated at x new, because y new is just a function and I am calculating the value of this function at every x new. And then I also superimpose on that my original data as solid lines. So you can see that it has plotted and it has fitted into a straight line. So our original data was from -10 to 10, but this, given we now understood that it is a straight line, it interpolated or extrapolated the data, and we have also interpolated the data. So we have our data, we had only 10 points, but now in between you can find the value of this function at any point. After you fit your data to a given function, a given polynomial, and you're happy with that polynomial, you can extrapolate the extra data which probably you did not measure or you did not get from your experiment or numerical experiments. Okay, so this is a good way to calculate intermediate things. So this is one of the things which you can do. You can fit your data, you can tell whatever if you have data, you can fit to any polynomial. If you understand that your data looks like a polynomial function, you fit it to this polynomial and you find out which is the best fit. Okay, so now sometimes you also, you have this data which is straight line, already. Okay, this is a simple equation and you want to calculate the value of it at some middle point, which you don't know. Okay, for a simple equation like this, what I will do is I will put x is equal to 0 or whatever value, and I will calculate what is my y. It is simple. I mean, I can calculate it by hand, but you don't need to do that also. You can I just defined y new, right? Y new as the poly 1D of the polynomial coefficients. So I'm going to, so for here I calculated y new for all the x new points, and I got the straight line. So if I want to know y new at what is this function at, let's say 0 or 0.5, I will just write y new of 0.5 and I will get the value. Even for y new of 0, let's see, because I would not have the 0 as a point, so it would be 5, which is correct, right? So I mean, I don't know how you sometimes you need this kind of data where you want to find the value of the function exactly. So this is a good way to do it. So this is a simple example, right? So anyway, you can do it like this. Now let's introduce another function, another thing, which is random.rand. So what I did now is I define a new y new, which is y, which is my straight line, plus np random.rand, and 10 is the shape of y. I mean, what is the size of y? So I'm going to add random numbers, which this function, what it gives is, it will give you random numbers ranging from 0 to 1. So given it is from 0 to 1, I increase the amplitude a little bit by multiplying it with 5. And now let's plot and see how it looks like. So the data, so it is a data is I have disturbed the line. So it would be something which you would get in your experiments, right? You won't get straight, or even in your numerical experiments, you won't get something like a straight line or a perfect polynomial or what. So I just randomized the data. So now again I try to find the polynomial coefficients of this function. Inherently I know that it is a straight line which has been disturbed a little bit, but anyway I know it looks like a polynomial function and I will try to fit it. So what do I do first? I calculate the polynomial coefficients by writing NP polyfit x, the number of points I have, and the data corresponding to these points, and I say let me fit it to a second order polynomial. and then I find the y fit, the data new fit, which is NP poly 1D of this coefficients which I calculated. But I need to calculate y fit for all the x new values or x values or whatever values you want to find. So I'll just run and see what happens. So this is your original data scattered away, and it has fit into a second order polynomial. So I will try to find what are the pole coefficients. Pole underscore COE FF, I defined it like that, and it is like this. So you have for the x square term, you still have a it could be negligible, but a non-negligible term, and then it's more like a straight line which is shifted by 7.8 and with a slope 2, but has a it could be negligible. It's fit into more like a straight line. Okay, it's not completely zero, the quadratic term. So you have this data and you can fit it. So this is how you do it. So if you have a data and you think it is a polynomial, you can fit it with Polyfit, and then you can plot the polynomial using poly 1D. It would be a function, and you have to give the corresponding values for which you want to plot it. So this is very simple, and you can do like that. Now if you know if it is something else like a trigonometric function, sine or cosine, and the data would look something like that, you can use curve fit from the SciPy module. So that we will discuss at some other point. So for now, I hope you will experiment with this Polyfit and try to use it in your research. Thank you.